All right, so let's take a look at the new lesson. Problem of the day, actually, you should have had a little bit of an idea of how to do exponents from Algebra 1. But just to refresh your memory of what you've learned last year, we're going to take a look at it. It says, write out the following exponents in log form. What do you observe in each problem? First one is done for you. All right, -5 quantity to the third power is not like -15 by multiplying them. You write them out, get -125. If I do the next one, I get 7 squared is 7 times 7, which is 49. And C, be careful here. C and A are different. You see how A there's parentheses and C there's not? That means I just write the negative once and I only write 10 twice, which gives me -100. So there is a difference between C and A, just so you know. D, you can actually, it's understood that each power is 1. So for this one, before I actually talk about the ones, let me backtrack for a second. Quantity cubed is xy 3 times. Which, if I want to simplify, that means, I might type this one out here. I get what? X to the third, y to the third. I'm going to squeeze this over here for a second. So how did I go from, I wrote 3 times, now I say I have 3 x's, 3 y's. What you could simplify to is that you could distribute the 3 to each, all right? I think I'm going to write some of these out here. The next one here, let's see how many x's I have. I have 2 x's, 3 y's, an xy, which if I count them, I have what, 1, 2, 3 x's. So x to the third, y to the fourth, and let's write it out for the next one as well. The top, I'm going to get x, x, and then 5 y's. That's all over x with 3 y's. Now what you'll notice here is I can start to cross out one of each from top and bottom. So there's a set of x's, set of y's, and they actually cancel out from top to bottom. So let's see what I'm left with here. I'm left with 1 x up top. Actually, type it over here. Y squared. And that's actually everything. Things left in the denominator. So what you'll notice is I wrote them all out to see what cancels out, but what you could also do is subtract your exponents. And for the last one here, let's see. Actually, I'll write it first. I'm seeing it twice. And actually, I just might type it. So 3 x's. Bottom, I have 2 y's. Like so. And if I type that out as a final thing, make them one big fraction, I have what, x to the 6th over y to the 4th, because there's 4 of them. And that would be my final answer. So you see what you could do, I have 6 of them. How do I know a shortcut? 3 times 2, and y to the 4th is 2 times 2. So let's take a look at all these properties here if you want to read over them. 5.1, use of properties of exponents. We sort of reviewed them a little bit in the problems of the day there. First one's product of powers. What that means is if you have the same base, you could add the exponents. Power of a power is where you multiply the powers together. Power of a product, you distribute the m exponent to both. Negative exponent, we never like to deal in the final answer as a negative, so we flip it. Zero exponent, anything to 0 power is 1. Quotient of powers is where we subtract the exponents, and power of a quotient is distributing the power to each of them. So let's get some use out of actually setting these up. I know I have power to power here. First of all, though, I can't combine these two bases because they are unlike terms. One is a -3 and one is a 5. So the bases are not the same. But I could actually multiply these together. So I get 2 times 3 times 5. Now there's no exponent originally, so it's a 1 times 3. So we're just distributing the powers to each. Let's just simplify that here. I could actually get rid of the parentheses. So you could get -3 to the 6th power times 5 to the 3rd. If we actually multiply them out, we get -729 times 125, which is -91,125. Let's take a look at the next one here. Don't forget, though, before I actually start, this is always if there's no exponents of 1, so let's just add that there. They both have the same base in this case, so I can actually just add the exponents as my rule. The -8 to the 4th power, which is the same as saying 4,096. So really you could do it either way. I'm okay with like this part with the exponents, and then here's your final answer. But if you can multiply it out, you might as well show the work to get a final number there. Example 2. Now here we can't really multiply them out because we jump to variables, right? So with example 2, I'm going to start with the W here. Oops, wrong thing here. I know they're all W's, so I could add up all their exponents. So we would have W to the 5 plus -8 plus 6 power, which is equal to W to the 3rd. So you're just combining each of the terms there, each of the numbers. So that simplifies to W to the 3rd. Now the next one. A couple ways you could do it. I'm going to go ahead and distribute the negative exponent first. So that's to the -2 up top. And then D would be to the what? -4 times -2, or D to the 8th. Get that first. And remember, we don't want to deal with any negative exponents. So this piece up top is going to move down to the bottom, which means it'll be over 1. Wherever you move it top to bottom or bottom to top, we'll get rid of the negative sign. So my final answer is 1 over c squared d to the 8th. Because once again, we could move it. There's nothing up top left, so we need to place a 1. Do not move the d to the 8th. If you move it, it changes to negative, so just keep it as is. Let's take a look at the next one. C. We have fractions, so first thing I'm going to do is simplify 16 divided by 2, which is 8. So 16 divided by 2 is 8. Then we have A. Let's subtract them. I usually take care of the negatives at the end. So negative 3. If you see at the bottom, it's going to be minus 5 because we're subtracting them. Then b squared. Get 8a, the negative 8th, b squared. And remember, we want to get rid of that negative, so we could keep it 8b squared over a to the 8th. So we flipped it down to make the a positive now. All right, so let's take a look at the next one. Power to power, so let's take care of that first, where we multiply the exponents. Negative 3 times 2 is negative 6. Y to the 3 times 2, which is 6, over x to the 5th, y to the 6th. And now we could subtract our x's. X to the negative 6 minus 5. When you subtract them, remember, it comes back up to the top, 6 minus 6, which equals x to the negative 11, y to 0. Now what you see here is we need to move the negative 11 down to be a positive, but don't forget the y to the 0 is just 1. So your final answer actually is 1 over, and I'll write it out, x to the 11th. And that's our final answer. Now it's scientific notation. We write it with a single, you might remember this from science class, we write it with a single number. The C has to be a number from 1 to under 10, it has to be less than 10 because it's a one-digit number, and then it goes to some exponent. So how do I solve these, writing scientific notation? Let's take a second and multiply these numbers first. 8 times 4 is 32, times 10 to, now the reason why we're looking at these in this lesson is because it's exponent rules. We're multiplying the base of 10, so we add the exponents together. 7 plus 3 is now 10. Now scientific notation, it has to be a single digit number. This is a 2-digit, right? So if I move the decimal over 1 to the left, that's 3.2. And that makes this, if you go to the left, this number goes up. So 10 to the 11th now. So we moved to the left, we add a digit. If we go to the right, we subtract a digit. Now the next one, let's follow rules. 6 times 10 to the negative 4th over 9 times 10 to the 3rd. Let's divide 6 ninths. 6 ninths, maybe I'll write it down here. 6 divided by 9 is 0.667. I'm dividing them. If I subtract my exponents, negative 4 minus 3, negative 4 minus 3 is negative 7. Now you'll see this time around, you see this is not a one-digit number. It's less than that because it's a 0. We want to move it over 1 to the right. When we move it over 1 to the right, we're going to take 1 away, go less than negative 7. Now be careful with saying less than negative 7 because on a number line, less would actually mean negative 8. And then that's my final answer. All right, we have one last example here. Example 4, write an expression for the volume in terms of x. All right, so we know volume equals length times width times height. We're going to plug it in and simplify. Take a minute to do that for me. Okay, so length times width times height. It doesn't matter which one's width, which I did length times width times height. All right, and we have it there. We plug it in and simplify. 2 times 5 is 10. I have 1, 2, 3 x's, hence x to the 3rd. And we're just going to keep the 3 in the denominator because it was part of the fraction. All right, that's it for today. I'm not going to show it to you, but I want you to do the problems of the day and the homework at the end of this lesson packet.